So let me just very, very quickly just explain who Corning are and what they do. That's very easy to do. So Corning is the biggest manufacturer of optical fiber in the world. There's more Corning fiber installed around the globe than any other manufacturer. And we also manufacture the hardware and connectivity solutions specifically for fiber to the home. So that gives us a good position to be here talking about this topic. So I cover a very wide area as market development manager. I cover Europe, Middle East and Africa. And every time I come to Africa, one of the things that really strikes me is the diversity in Africa. So Corning is an American company. There's lots of fiber to the home activity in America. And one of the things about that market is that there is also a lot of uniformity. So obviously everybody speaks one language. And there's a lot of sharing of technical requirements. The installation environment and the installation practices are very similar across all of the US. I do a lot of my work in Europe, and one of the things that we have to deal with is the variation throughout the region. So, of course, in Europe, they speak, many different languages, 23 official languages in Europe, and each country wants to do their own thing. When we come to Africa, those 23 languages become 2,000 languages. So you can imagine the level of diversity that we have to deal with. So that presents some challenges. And these are the three main areas of the challenges that I want to speak about today. So the first one is around money. And you could say that that's a challenge wherever you are, which is true. But particularly the main aspect here is really the requirement to build fast and monetize the investment to start bringing revenue back from what you've built. Another area is the availability of the skilled splicing resource, which the Minister touched on in his speech earlier. The second one is the range of installation environments, as I mentioned, this diversity, and the demands that places on product flexibility. And the final one is network security, and again, the demands that places on the products and the reliability. So all these three aspects are really in relation to Corning's business, which is, as I mentioned, the outside plant connectivity. So let's look first at the money side of things. So optical fiber is this amazing thing. It's completely changed the world. And when we have an optical fiber to every house, it will change the world even more. But one of the challenges with fiber is it's actually very, very difficult to join. So if you imagine a piece of fiber is 1/8 of a millimeter in diameter, the part of the fiber which carries the optical signal is about 1/100th of a millimeter in diameter. And to join that, you have to align it to within about 1/1000th of a millimeter in diameter of accuracy. And then you have this very specialist arc welding process, in effect, to join the fiber, fusion splicing. And that's not new. That's been around since the start of optical fiber. But in the fiber to the home networks, there is a lot of joining of fiber to be done. So historically, if you're building a 96 fiber trunk route and you have an installer who's joining those 96 fibers, they set up to do the work and they do all the splicing, and they're using the skilled process most of the time. For a fiber to the home installer, that person is doing a lot of other things, and they're doing that in difficult places. So that person is also maybe digging holes, across the customer's the front of the customer's house. They're moving furniture around inside the house. They're commissioning the service. They're doing a lot of things, but they're using this very specialized process just for a very small proportion of their time. So we need to find different ways of actually joining the fiber, of making that connection of the drop cable to the customer's house. So we need to replace the fusion splicer, an optical cleaver, a specialist toolkit, and very importantly, the skilled person in his controlled environment to do the work with optical connectors. And again, there's nothing new about optical connectors. They've been around for many years. But historically, optical connectors have been used in controlled environments. I'm sure there's optical connectors inside this building. But what's different here is the hardened nature of the connector. So the optical connectors can be used in any external environment where you build the fiber to the home network. So we have this difficult and very time-consuming specialist process, which becomes a simple plug-and-play process. So the people doing it, you can see the process that they're actually engaged in is very different. So what are the benefits of pre-connectorized solutions? So we build these into three different categories: faster, easier, and reliable. So for faster, we really focus on the customer connections. So you can do more connections per day with fewer installers. And some operators have reported using hardened connectors and doubling their efficiency of their installation workforce. You also get a faster homes passed deployment because the terminals that you place close to the premises are all pre-terminated. So the terminal you can see at the bottom there, all the fibers are terminated in the factory, and the only process to install that is really to fix the terminal, either on a pole or put it into a chamber, and there's no work required at the fiber level, so you can pass the homes more quickly. And what that means is you get this shorter time to actually make revenue. So in terms of easier, the customer installs can be done by much lower skilled technicians. So what we've developed is a process where the customer installation is much more like a copper installation process. So someone who's used to working with copper coax, terminating coax connectors, can very, very easily be transferred to fiber to the home installations. And what you get there is then the avoidance of skilled labour shortages, which I'll touch on a little bit later. So none of these advances are any use if it's not reliable. The reliability is built into the products. So all this work at the fibre level is actually done in factories in quality controlled conditions. Another challenge with fibre is it's actually very difficult to test. But when you have these pre-configured connectors, you can use those as test access points. So that's good for the commissioning and troubleshooting of the network. And it's a modular upgrade path, so these are plug-and-play components. So you can swap out components, you can change different aspects, and you have this much lower skill level evolution of the network. So when we look at the cost, we can look at these analyses in many different ways, and this is just a very simple sort of consideration here. So this is the cost per home based on a take rate of 40%, and what we're looking at here is just the outside plant materials, so all the cable, all the joint closures, the terminals, and the cost to install those, so the cable installation and the splicing labour. It doesn't include the civils and the duct and the electronics. And as you can see, for a splice solution, it's quite a typical split there of about a third of the cost is in the materials and about 2/3 of the cost is in the installation labour. If you go to a pre-connectorized solution, then the cost of the materials is higher, which you would expect because we're building a lot more into the components. But the cost of the installation is about halved, which then gives you a significant saving on the installed cost. And if we look at the variation of installed cost versus take rate, so yes, as I mentioned, we're building a lot more into the components. So the initial cost when you first build the network, the homes pass stage, may be slightly higher than a conventional splice solution. But as soon as you start connecting customers, you get a saving on each customer connected. So it's a nice linear relationship, and the more customers you connect, the more saving you make. And the typical break-even rate is only 6%. So you're making money very, very quickly. So I touched on this Africa-specific topic of availability of skilled labour. So, as I mentioned, the splice solution needs this specialist equipment and the people to actually do it and all their training overhead. But in any large-scale fibre-to-the-home deployment, that skilled splice resource will become more and more scarce. As I mentioned, the Minister spoke about that earlier. And here's just a quote from a report, a UBS global research paper on South African telecoms. So this is a recent report, February of this year, where they said certain private fibre-to-the-home providers noted a skills shortage developing in this area of the market, with the availability of technicians with appropriate qualifications a hindrance to last-mile connections. So there it is in an independent report. And you can easily do some sort of calculations on the time to install. So if you imagine a fibre-to-the-home build of 1,000 homes passed and connect about a 40% take rate, so that's only a very, very small fibre-to-the-home build, you know, one small suburb of a city. And the amount of skilled splice resource you need to install that is about the same as installing 500 kilometres of a long-haul 96 fibre trunk. So you can imagine if you scale that up, the impact on availability of resource is significant. I talked about the cost deferment, and this is just touching on one particular product which addresses that. So when I talk about cost deferment, only pay for the equipment as you need it. So this is the ultimate in plug and play, and with this particular solution, which is called FlexSnap, these assemblies are actually custom made for each individual street that they're installed on. So in this aerial assembly here, you can see, you know, that could be a 96 or a 144 fibre trunk cable. And at predetermined points on that trunk cable, we open up the cable in the factory and install this short, what we call a tether cable. So that could be a 4, 8 or 12 fibre cable. And we fusion splice that to the main cable and then cover that with what we call an overmold. So this is a flexible covering of that joint closure in effect. And then you can install that just like one straight piece of cable. So that main cable could have 10 or 20 of these overmolds, and you install it, and these overmolds all sit exactly at the point that you've designed it to be made to. And so you have all these points with connectorized ends. In this case, it's a multi-fiber hardened connector. And then when the first customer wants service at that point, you come and install the terminal and just connect it with this inline male to female 12 fiber connector. So you're saving on the cost of the terminal. And the next customer, you install the next terminal. So you get this deferred cost. So that's been a big advantage in terms of speed of deployment. And that's been used very widely in a number of regions throughout the world. So I spoke about the cost, and now let's speak about the range of installation environments, coming back to this diversity topic I mentioned earlier. So there's a very wide range of civils infrastructure, and that civils infrastructure may well be less developed in Africa than it is in other regions. So the range could be aerial, underground ducts, direct buried, on the side of buildings, using power infrastructure, in effect wherever it will go. And you can see the range of places that this equipment can go into. So aerial is a key one to focus on because aerial is the lowest cost civils infrastructure. If an operator already has an aerial network, they will continue to use it. If they're building a new network, if they're allowed, they will build an aerial network. So the products must be suitable for this aerial deployment. So when I talk about the products, I'm talking about network access points, drop cables, closures, and the mounting options need to be suitable for the range of aerial infrastructure that you get. So steel lattice, concrete or wooden poles, mounting the equipment on messenger wires, fixing it on building facades, etc. And the cables must be designed for very simple aerial low-cost fittings. And this is just a detailed example here of the way we've approached this. So these fittings that you see are very old technology. So these wedge clamps, it's a three-point part design using this taper arrangement. So the harder you pull on the cable, the stronger that taper crushes the cable. So the cable has to withstand the very high crush force. And you can see the design of that cable there. And what you see is the two white cylinders are resin-bonded glass, fiberglass rods, which provide the strength. And these are very, very strong under crush loads as well. And the fiber embedded in the middle. So that gives the fiber or the cable a very high crush resistance. And remember, this fitting works by crushing the cable. So the approach we've taken is we've taken these fittings, less than $1 each, which have been used for many years on copper cables, and designed the cable to use that fitting rather than have a special fitting for the cable. And these are just some examples of aerial deployment. You can see the terminals there, and you can just about see the fittings. At the very top of that right-hand picture, you can see the small aluminium fitting there. These are some other aerial deployment pictures. And you can see that the equipment often has to fit in an area where there's a lot of other equipment. There's a lot of other things happening, and that may well not belong to the operator deploying to the fiber to the home network. So you can see here some existing copper telecom, and in the picture on the right, you can see some coax tap points. And so it's a very uncontrolled environment. So the more rugged the products, the more likely they are to survive what they will have to withstand. And here's another picture showing some aerial deployment in a power utility network. So the drop cable, so this is the last cable between the terminal and the customer premise. You would think, well, that's a very simple cable. It's a very short distance. It's a very low fiber count, 1 or maybe 2 fibers. But when you think of the application, the drop cable actually has significant challenges. That drop cable has to be, well, low cost is very important because there's lots of it. But it also needs to be strong and rugged and stiff. It needs to withstand all these loads I mentioned about the aerial deployment. It normally needs to be black in color, small. The cable which goes inside the customer premise needs to be very small. It needs to be flexible. It needs to be normally light, white or ivory in color. And it needs to be low smoke, zero halogen or flame retardant. So there's two very different requirements in the same cable. And what we can do is we can build those two requirements into one cable. So the inner part is this internal cable. The outer part is the external cable. And the one on the bottom there has this, what we call fast access technology. So you can literally peel the cable open like a banana. You don't need any special tools. You can pull it open by hand and reveal the inner part of the cable over very, very long lengths very easily. So what you do is you route the cable to the house, you drill a hole in the wall, you open up the cable at this transition point, so the cable goes into the house as an external cable and then enters the inside part of the house as an internal cable. So you don't need a transition joint to convert the two cables. So that's very widely used in a number of different regions. So in terms of the product implications of this diversity, it's important to think that the civils costs can be up to 80% of the overall network build cost. So the key to that successful FTTH business case really lies in exploiting the civils that you already have. So the products must meet a wide range of universal applications. They must meet the harshest installation environment. And all the bits and pieces, it may seem simple, but it is important. So all the fitting kits must be included, and those fitting kits must suit a wide range of environments. And we have aspects of designing features into the body of the component, which actually help with those universal fitting kits. In terms of the cable properties, so that's more of a challenge because an aerial cable is different to a small light mini cable, for example. So that then puts challenges on the hardware such that the hardware must be compatible with a wide range of different cable constructions. So, moving on to the final part, which is network security. So that fibre to the home network, as I mentioned earlier, needs to operate in a very wide range of uncontrolled and unprotected environments, and it will be subject to disturbance from the outside world. So you can see here some examples of some terminals, sitting in flooded chambers, facade deployment where there's a lot of other equipment installed, and we also need to reduce the external risk for installation staff. So when these pre-connectorized solutions were first introduced, the question was asked, well, how do you achieve this level of cleanliness? So that's what the end face of an optical connector has to look like for it to work. And you can see, the core of the fiber, that white spot in the middle, 9 microns in diameter, and it needs to be that optically clean. But we're using it in an installation like that. And quite rightly, people question whether that's actually going to work. So I can talk about installation practices and cleaning equipment and things like that, but I'm not going to do that here. I'm going to say, well, let's look back at history, because these solutions have been around for a number of years, and one operator took that risk in 2004 when Verizon announced they were going to build a fibre to the home network. And basically, it paid off. They took the risk. So this is what they said at the OFC conference in 2005, that the drop is accomplished by employing a hardened connector to reduce maintenance issues. The drop may initially be higher than the splicing cost, but it can be done quicker and requires less skill. So that's a story I talked about in the first section. And then in 2006, when they'd been building for a couple of years, they were able to announce some of the results of that deployment. And in their earnings call in 2006, they made the statement, the outside plant troubles just go away literally to zero when we're doing this. So the operational performance of the equipment was seen to be proven. And that's paved the way for millions of homes passed. So about 25 million homes passed have been, homes have been connected with hardened connectors, not all with Corning equipment necessarily, but it's been a very, very widely deployed solution. So many followed after Verizon. So in the US, the Verizon build, about 18 million homes passed, is now tailing off, but that's been taken up now with AT&T, who are doing a lot of fibre to the home using hardened connectors. In Canada, Bell Alliant, Bell Canada are building using hardened connectors. In Brazil, Vivo or Telefonica are building using hardened connectors. The national broadband plan in Australia, the fibre to the home part of that uses hardened connectors. The fibre to the home build in Spain, one of the biggest builds in Europe, uses hardened connectors. And the UK, who are just starting on their fibre to the home build, are also using hardened connectors. It's been very, very widely deployed, and we're very close to actually now deploying the same technology here in South Africa. So how do we achieve that reliability? So one aspect is the test specifications. So IP68, which is the rating for dust ingress and water immersion. And so 68 is normally specified for underground equipment, and that should be specified for all equipment, whether it's used underground or used aerial or on facades. But with this equipment, it was developed in the US, and it goes a step further. So it uses the Telcordia specifications. So I mentioned about things being very similar in America, but one thing that is different is their climate. So if you imagine in Alaska, they have ice storms. In the deserts of Nevada and Arizona, they have dust storms. And they have, obviously, hurricane storms, which have been in the news in the last month or so. So the environmental climate that the products have to withstand is much greater than most individual countries in other continents. And so the specifications, these GR specifications, are very, very, very demanding. And there's just an example of some of the things that are specified in that spec, and I'll just pick out a couple of these. So the extended thermal cycle, -40 to +70, which is fairly typical for optical fiber hardware. But look at that, 100 cycles over 84 days. Normally these things are specified for 2 or 3 cycles. This one here, freeze thaw, might not necessarily be most relevant to Africa, but it just shows you the rugged nature of the product. So what that test involves is taking a meter cubed bath of water, putting mated connectors inside that bath of water, and then turning it into a meter cubed block of ice, and then thawing it out and then refreezing. And if you imagine what ice can do, can break open steel pipes, the forces are enormous, and the products have to withstand that type of environmental impact. Now, non-hardened connector solutions exist, so I've been talking about hardened connectors here, but the issue with non-hardened connectors is that when I say non-hardened connectors, I mean conventional connectors like SC or LC connectors inside conventional terminals. But with these, the installer has to go inside the closures for every individual connection. And that installer, their motivation is to do the job as quickly as possible and move on to the next install. So they're not concerned about the sealing and the fiber management inside those closures. And this is the kind of thing that you see with non-hardened connectorized solutions. And so reliability is severely compromised. You get high attenuation fiber breaks. So one thing that's relevant here, particularly in South Africa, is security for installation staff. So there's been an increased frequency of installation teams actually being targeted by criminals. So splicing equipment is very expensive equipment, and it's recognized as a valuable asset. And so the Fibre to the Home Council in Africa have done some excellent work here on reducing that by introducing the register of splicing equipment. But if you look at this here, if you have these hardened connectorized solutions, they just don't need that equipment. So if you're going to target either of those two people doing their work out in any part of the country, well, one is going to be more of a target than the other. So that's another advantage of hardened connectorized solutions. So these products continue to evolve. They've been around for quite some time, but they're always evolving to different applications, and you can see some of the evolutions of those products. So there are single fiber versions, there are multi-fiber versions. And with connectors, it's important to have universal solutions. So there are formats of this connector. The Corning connector I've been talking about is the OptiTap connector. And that's the most established hardened connector solution around the world. And there are a number of different manufacturers licensed with the technology. So it's a multi-vendor solution, which many big vendors or many big operators insist on. And finally, then, to summarize, so pre-connectorized solutions, they offer significant benefits for fiber to the home deployment, specifically in Africa. They give a faster network rollout, more customer installs per day. It's low-skilled plug-and-play solutions. They're reliable and proven solutions, which you can tell by the number of deployments I've just spoken about. And there's this reduced dependence on this scarce, skilled installation labor. So the fiber install is very much like a cable TV install. It's like a copper install, so this simple redeployment of existing resources. And the outside plant products need to be flexible to meet the very diverse demands of the environment that they sit in. And that reliability is proven through successful mass deployments throughout the world. So the Corning stand is just outside, right in the middle of the floor. You can't miss it, absolutely. Just as a final note, and to add a little bit of fun to the proceedings, we're running a simple fibre to the home quiz. So we're all fibre to the home experts, but we have a competition going, which is online. Just go to the booth, and we can show you that. And you can win an Apple iWatch. So if any of you are interested in that, then go ahead. And just to reward anybody who's been kind enough to come and watch my presentation, Think spider's web, not cat's whisker. Okay, so hopefully that's piqued your interest. Okay, so thank you very much, and that's the end of my presentation.